Hey guys, welcome to my classroom, or actually my wife's office, which is now my classroom for the foreseeable future. She's my cameraman, so I just have to make her dinner every time she films me. So we're having Chinese tonight. Anyway, so we're gonna start getting into new things. So I've got to try and do my best to get you to learn it. So we're going to introduce a few things today with similar figures. So hopefully you guys have, today's Tuesday, so hopefully you've gotten your angle riddle worksheets done, con and quizzes, the prime factorization. I know there's a lot. I laid it out all on Canvas, so I've had a lot of students that are emailing me their papers, let me know that they finished things. That's great. I'll get to grading tonight. I'll continually grade and get grades in the grade book. But if you do have those angle worksheets, you can just take a picture and send it to me. Okay, that's fine. I'll take it. So, but for the next week, we're going to deal with similar figures, scale drawings. So there's going to be a quizzes tomorrow on 4 concepts, basically, dealing with similar figures. So, before we get going, I just want to kind of talk about what similar means. So similar can mean things that we have in common. So, for instance, boys are similar with boys, obviously because they're boys. Football players are similar with football players, right? Band people have similar likes. So we have things that are similar. So how do we use that in math? So with what we're going to do today is we're going to talk about polygons, triangles, rectangles, and we're going to see why they are not similar and these characteristics to each. So we're basically going to cover 4 things. We're going to cover what are similar figures, what these corresponding parts are, what scale factor is, and how do we determine whether 2 triangles are similar. And then on Canvas, I will post this video, plus I will post another video which kind of pertains to each small thing. Because I know a lot of you will not get this just from this video, so you'll need more support. You'll need to keep doing quizzes. You'll need to look at a con. Maybe you'll also assign a con to help you with these things. So immediately it's not going to happen. So watch this video as many times as you need to. Watch the videos that I post on Canvas tomorrow with each concept. So if you're fuzzy on scale factor, watch the scale factor video before you just dive into quizzes. So I've got a bunch of whiteboards that I've put together here. So it's like my own little big whiteboard in a bunch of different small whiteboards. So we're going to go through each. I'll go through it slowly. Hopefully you get a kind of a grasp of what we're talking about. So first I'm just going to give you the definition. So this is just like we're taking notes in class. So what are similar figures? Here's your first kind of note. So, Ange, can you see that all right?
Mm-hmm.
All right, so similar figures. What does it mean? Like, if you were to Google similar figures, what's it going to say when you Google it on the internet? It's going to say the figures that have the same shape but not necessarily the same size. Okay? So, for instance, we'll kind of use this one. We're going to use this one at the end. But here's something that, like those 2 triangles, right? We're going to look at those. Wow, those look kind of similar. So, do you know for a fact that they are? No. Are we going to use math to figure that out? Yes. We will prove whether those are similar triangles or not. That's one of the goals today. So you can't just look at it and be like, you know what, they look similar. So we have to do it with some math, but that's really what similar means. So just think if you copy something or you enlarge something or you shrink something, it's the same shape, we've just changed the size of it. So you're going to hear me talk a lot about corresponding parts. So there are 2 things that have to occur with similar figures. 1, the corresponding angles are equal. Okay, we'll talk about what corresponding means, but they have to be equal. If they're not, you don't have similar figures. You're going to hear me use the word corresponding. It also means matching. And the second thing that's the most difficult, but we've done proportions, is that the corresponding sides or the matching sides must be proportional, not equal. Proportional, okay? Those equal ratios, those 2 fractions that we write when we compare two numbers, all right? So that's your book definition of what similar means, all right? Now let's see what it is in action, okay? So my next one is, where is it? Okay, corresponding, I think. I don't know if this is the one I just had up. Maybe, may not. So what are corresponding parts? So on your quizzes, you're going to see 2 figures. You're going to say, what angle matches angle A or corresponds to angle A? Well, what does that mean? So there's 2 ways you can do it, and I'll show you both. First way, we're going to say that these are similar. So if you didn't know, this is the similar symbol. So just like an equal sign makes it equal, we talked about congruent last week. A similar figure just says, hey, triangle DIG DIG is similar to triangle CAB, CAB. That's all that's telling us, is these are two similar triangles. So what do corresponding parts mean? They mean that they're matching parts. So from a picture, you can do it from a picture. So you can look at this and be like, oh, angle D has this right angle. What matches angle D on the smaller triangle? There's angle C, right angle. Okay. Now I go up to here, angle I, this one arc. Well, you can look here on the smaller one, which one has one arc? Well, it's angle A. Those match. And then lastly, I have angle G. What matches angle G? Well, it has two arcs. I go right here. This is nice because these are in the same spot, right? They're facing the same way, but sometimes they'll rotate things around, and it's not so easy to see the matching parts. So it's nice to be able to kind of look at these arcs because they've got to give it to you. So you can see that. But those are your matching angles. And then from there, you just look at your matching sides. Well, side DI, well, it matches side CA. Those are corresponding parts. Are they equal sides? No. Are they equal angles? Yes. Side GI or side IG matches AB. And it goes in the order of the letter. If I say side IG, I've got to say side AB. And then lastly, side DG corresponds to CB. Or side DG matches side CB. Okay, so that's the corresponding parts. And I'll show a video just with corresponding parts on YouTube if you're confused with what corresponding parts are. So it's nice with a picture. Okay, that helps us when we see it. But what if you don't? What if you don't have a picture? Well, we go to this. These are called similarity statements. So without a picture, you can absolutely find the corresponding parts. So these are actually three ways to say the same thing. You were basically saying triangle ABC is similar to triangle DEF. Now, if you didn't have these two, if you didn't have a picture, you could still tell me the corresponding parts because it goes in order. So you could say angle A matches angle D. You could say angle B matches angle E, and lastly, angle C matches angle F. So without a picture, you can still find those corresponding parts. It's here. And then you could also go to line segments. AB matches DE. EF matches BC. Or you could go FD matches CA. So you don't need a picture. You can do it from here. And then notice the other two, all I've done is rewritten this two other ways to say the same thing. Notice that the matching parts still match. I could go BCA. Well, BCA and EFD. Well, notice B still matches E. B matched E. C matches F. C still matches F. All I've done is just rearrange the letters. As long as they still match, I can write these many different ways. And the third way it is CAB, CAB, and FDE. And if you look at those matching parts, you'll see that they all match. Just three different ways to say the same thing. And I can come up with more. Okay, I've just come up with three. But notice, C matches F, C matches F, C matches F on all three of these. Okay, it's called a similarity statement. All right, that's it. All right, next. You guys aren't sleeping yet, are you? Okay, because I know some of you do in class. All right, next, scale factor. Where's my scale factor? All right, and I know I'm giving you a lot, right? It's a lot to digest. Fortunately, I have email. You can communicate with me. You can kind of ask questions, say, hey, Mr. Foreman, I have no idea what you're talking about with scale factor, which is probably the toughest of the things we're going to talk about today, quite honestly. So what is scale factor? A scale factor, factors are multiplying, remember, right? A factor is just something you multiply by. So when they say, what's the scale factor of similar figures, they want to know, what do I multiply to go from one figure to the other? So if I have two similar figures and they say that they're similar, they want to know what the scale factor is, because if they're similar, there's a scale factor. So all it's saying is, what do I multiply by one to get to the other? If I'm going from the small one to the big one, or the big one to the small one. And I'll tell you how you do that here in a second with numbers. So what we use is we use this new. If we're going from one to another one, the new one is what we're going to. The old one's what we're coming from. All right? So let's look at something with scale factor. All right? Scale factor. Okay. With some of these, you're going to be able to do it mentally. So some of you are fully capable of looking at this and knowing exactly what the scale factor is to go from one to the other. But they got to be similar. So say if I want to know what is the scale factor to go from small to big, right? If I'm going from small to big, I want to know what the scale factor is to go from one to the other. Remember, it's new over old. So I'm going from small to big. So all I do is write basically a fraction of the ratios of my sides. Well, if I'm going from small to big, what am I multiplying? Some of you can see it. Oh, to go from 6 to 12 and to go from 4 to 8, I'm multiplying it by 2. You don't need to set this up, but maybe if you have decimals, it's a little more difficult. So all I do is just set up a fraction. 6 to 12, small to big, I go 12 over 6 or 8 over 4. There's my 2. Okay, that is my scale factor. Now if I want to go from here to here, well obviously it's getting smaller, so it's going to be less than 1. So you write it as, it's old, goes on the bottom, new goes on top. So we're going small over big, 6 over 12, 4 over 8. That is 1/2. Okay? That's scale factor. Like I said, it's the most difficult thing of what you're going to do. I will post a video. I actually found a pretty good video on scale factor that I'll post on your campus page tomorrow. So they're going to see a couple scale factor problems on quizzes tomorrow. They just want to know what do I multiply it to go from one to the other. All right? My wife looks like she's confused, so that worries me. Are you confused, Ange?
I'm fine.
Okay. The last thing, like I said, it's a lot that I'm giving you today. Okay? So, the last thing for today is, are they similar? Okay? So I'm going to put this. So they're going to give you 2 triangles before I put that there. And what they're going to ask you is, are these 2 triangles similar? And how do we use math to figure that out? So what we do is we look at these 2, and you can't just say, well, yeah, they look similar to me. I'm going to say yes. No, we've got to use math. So what we do is, let's put this here. Remember, the 2 conditions for similar figures is 1, matching angles have to be the same. They have to have the exact same measurement. So we're going to look at our matching angles. Well, from here, angle B matches E. We could see it from here. B is the second letter, E is the second letter, or from the picture. Well, B and E are both right angles.